And we're going to look at adding, subtracting, multiplying, and maybe even dividing square roots. So let's get started. We have square root of 8 times square root of 2. We're multiplying here. I guess the big question is that the same as square root of 16? Well, we know what the square root of 16 is. It's 4. And if we can show that this is also 4, then I think we can prove that multiplying 2 square roots is the same thing as having it inside of 1 square root. So let's see what we can do. Let's simplify 8 down to 2. Square root of 8 is square root of 4 times square root of 2 times square root of 2. That's the other one. Okay, so square root of 4 is just 2 times the square root of 2 times the square root of 2. Well, when you take a square root and times it by itself, you're just going to get the number inside. It's just 2. It kind of undoes itself. You're squaring the square root. There are reciprocal properties there. So you've got 2 times 2, and that equals 4. So we can say that the square root of 16 equals the square root of 8 times the square root of 2. You can break them apart or put them together like that when you're multiplying. Okay, so let's take a look at maybe one. Let's try square root of 9 times square root of 4. That could also be written as square root of 36. And what is the square root of 36? I hope you remember, it's just 6. I put some perfect squares in here to kind of help you out. What's the square root of 9? It's 3. Square root of 4, it's 2. And 3 times 2 is 6. So 2 different ways to get to it there. We can look at them separately, or we can multiply them together. Either way, you get the same thing. Okay, let's take a look at the next concept. This involves the commutative property, meaning we can move numbers around. To commute means to move. So let's see, this is saying 2 times the square root of 3 times 4 times the square root of 2. 2 square roots of 3 times 4 square roots of 2. Let's break it up like this, 2, and we're going to put 4, we're going to do the old switcheroo on 4 and square root 3. So now 2 times 4 is 8, and square root 3 times square root 2 is square root 6. And here you have it, 8 square roots of 6, same thing as this here. If you were to plug this into your calculator, don't forget to close your parentheses on the 3 there, and then plug this into your calculator, you should get the same exact answer. So hopefully that helps a little bit with multiplication. Let's take a quick look at division. If I have, let's just say square root 12 divided by square root 2, we could say that's the same thing as square root 12 over 2 under the square root, so the square root of 6. Okay, so that's one way to write it, is square root 6. Something really important here, and there's a method for taking care of this problem. The problem is this. If you have a square root in the denominator, remember a square root, if it's not a perfect square, is an ongoing, non-repeating decimal. And so what that means is the decimal place goes on and on forever without any kind of repeating pattern, and you can't divide by that kind of number. So one way to take care of this is to do this, square root 12 over square root 2 times 1. And you're saying, what's the 1 for? Well, this is what the 1's for. Square root 12 over square root 2 times square root 2 over square root 2. We turned 1 into the denominator divided by itself, which is just 1, and timesing something by 1 doesn't change its value. Now let's just multiply straight across and see what happens. So square root 2 times square root 2 gives me square root 4, which is just 2. It's just 2 there. And square root 12 times square root 2, that gives me square root 24. Square root 24 over 2. Now, let's take a good look at 24, because I think we can simplify that a little bit. down to square root 6 times square root 4. And what is the square root of 4? It's 2. So we got square root 6 times 2 over 2. And we're back to square root 6. So I hope that helps you understand how to get that square root out of the denominator. It's just not legal in math terms. You're not supposed to divide by a square root. Just times the top and bottom by the same number, which is the square root that's in the denominator, and it takes care of it for you. Okay, that's multiplication and division. Let's take a look at some addition. So, what do you think of that idea right there? Square root 9 plus square root 4 equals 13. I hope you're seeing something wrong with it, because it's not right. I'm going to just X it out there. Let's simplify this a little bit. The square root of 9 is 3, and the square root of 4 is 2, and that equals 5. Okay, so if 3 plus 2 equals 5, 5 would have to equal that square root of 13. Does 5 equal square root of 13? And I hope you're answering again, no, it does not. So you can't just add the 9 and the 4 to get 13. You have to take care of the square roots, that issue there. So let's see what we can do with this. I'm going to put another problem up there. I'm going to go square root 20 plus square root 5. And this time you'll notice these are definitely not perfect squares like they were up here. So we can't just simplify them down to whole numbers. It doesn't quite work. But let's see what happens if we do try to simplify them. So I'm going to take the square root of 20. The factors of 20 are 5 and 4. So square root 4 times square root 5. We're simplifying it here. And we took out that perfect square of square root 4. So you have 2 square roots of 5 plus, over here we have 1 square root of 5. And now, originally we couldn't add these together. Couldn't do it. We knew you can't get square root 25. That's not right. So we tried to simplify them both. And once we simplified them, it's like we have like a like term there. Kind of like you're adding x's or something, but we're adding square root of 5. So if you have 2 square roots of 5 plus 1 square root of 5, that will give you 3 square roots of 5. And there you have some kind of an answer. So this is a justification for simplifying your problem, because when you simplify, then sometimes you can add the square roots together. If let's look at another one. Let's go square root 8 plus square root 4 plus square root 2 plus square root 5. Oh, this is crazy. Okay. Let's see here. First of all, any perfect squares in there? Oh yeah, square root 4 is just 2. That's nice. Okay, let's look at 8. That breaks down to square root 4 times square root 2. And what is the square root of 4? It's just 2. So we got 2 square roots of 2 for 8 plus 2 plus the square root of 2. That doesn't break down at all. And then the square root of 5, that's a prime number. That doesn't break down. Okay, so which of these can we combine together? Hopefully you're seeing a square root 2 there and a square root 2 there. So we got 2 square roots of 2 plus 1 square root of 2. That's 3 square roots of 2 plus 2 plus the square root of 5. That's as simple as you can get it. Now, if you really needed to combine these numbers together, you could do a decimal approximate for this and a decimal approximate for that and get a good idea of what you're at. But in terms of keeping the numbers at the absolute correct value, this is it here. That's as simple as we can get from there. So I hope that helps a little bit. I'm not going to do a subtraction because it's just the same thing. Oh, let's do one. Let's do one subtraction. Let's go square root 32 minus square root 2. Okay, square root 32. I'm seeing a 16 times 32. Those are my factors there. 16 happens to be a perfect square. 16 times 2, same thing as 32, minus the square root of 2. And what is the square root of 16? It's just 4. So 4 square roots of 2 minus 1 square root of 2 gives you 3 square roots of 2. I hope this helped you understand adding, subtracting, multiplying, and dividing with square roots.